Explainer. Today, we are diving into something, well, kind of weird. A huge contradiction that's happening right now at the very heart of software development. We're calling it AI's productivity paradox.
All right, so let's get right into it. There is this massive, and I mean massive, disconnect happening. It's all about how much developers are using AI tools versus how much they actually trust the stuff those tools spit out.
And this is where it gets really stark. Look at these numbers. On one side, you have this incredible adoption rate. 84% of developers are using AI tools. That's almost everybody. But, and this is a big but, on the other side, only a third of them, just 33%, actually trust the code that these tools generate. I mean, that is a huge, huge gap.
So what gives? Why on earth are developers using tools day in and day out that they just don't trust? It doesn't really make sense, right? Well, that's the big mystery we're going to try and solve today.
And you know, if you look at how this has changed over time, the picture actually gets, well, it gets darker. This isn't a problem that's fixing itself. It's getting worse. Just think about this. In a single year, AI usage went up by 8 points, which is a lot. But at the same time, distrust, it didn't just go up, it skyrocketed by 15 points. It feels like that initial honeymoon phase is over, and now we're dealing with some serious real-world frustration. And all of this whole crisis of trust, it's leading to what people are calling the productivity paradox. It's this idea that all that speed AI promises, it's just getting eaten alive by the hidden costs of its mistakes.
I want you to really let this number sink in. 45%. That's nearly half of all developers saying it now takes them longer to fix the code an AI writes than it would to just, write it themselves from scratch. That is the exact opposite of what AI is supposed to do. It completely flips the whole promise on its head.
And here's where the real frustration is coming from. It's not that the AI is just making obvious mistakes. No. 2/3 of developers say the biggest headache is code that is almost right. It looks good, it seems plausible, but buried deep inside are these subtle, nasty little errors. We're not talking about a typo. We're talking about fundamental logic flaws that are a total nightmare to track down.
So what you end up with is this new kind of technical debt. People are starting to call it productivity debt. And it's a great metaphor, right? That initial burst of speed you get from the AI, think of it like a high-interest loan. You get the cash up front, but you're going to pay it all back and then some when it's time to review, debug, and maintain that code. Okay, so why? What is the deep fundamental reason these incredibly powerful tools are so, well, unreliable? It really comes down to a clash of two totally different ways of thinking. Okay, this is the absolute key to understanding everything. For decades, all the tools developers have relied on, compilers for example, they're what we call deterministic. They follow hard, provable logical rules. 1 + 1 is always 2. But an LLM, the AI, it doesn't work that way at all. It's probabilistic. It's basically a super advanced pattern matching machine. It's not asking, is this answer correct? It's asking, based on all the data I've seen, what is the most likely next word? Is this probable? And those are two very, very different questions.
And that right there, that's why AIs hallucinate. You've heard that term, right? It's not a bug. It's not something that can be fixed. It's a fundamental feature of how they're designed. Their job is to fill in the blanks, to give you the most statistically plausible sounding answer, even if that answer is just completely and utterly wrong.
So, okay, if the big problem is all this fuzzy probabilistic uncertainty, then what's the solution? What's the antidote? Well, it's got to be the polar opposite, right? It's got to be cold, hard, mathematical certainty.
And that brings us to this field called formal verification. Now, this is a real game changer. Think about how we normally test software. We run some tests, and if one fails, great, we found a bug. But if they all pass, what does that prove? Not much, really. Traditional testing can only prove the presence of bugs. It can never prove their absence. Formal verification is different. It uses mathematical logic to analyze the code's structure, which means it can actually prove that entire categories of bugs are just not there. It's like the difference between spot-checking a few pages of a book versus mathematically analyzing the entire manuscript.
So how does it work? Well, basically, you create this super precise mathematical contract for what your software is supposed to do. This contract covers two main things. First, safety properties, making sure a bad thing can never happen, like two users can never get the same ID, ever. And second, liveness properties, making sure a good thing eventually happens, like if a user submits a request, it will at some point get processed.
Okay, that sounds pretty cool in theory, maybe a little abstract. But what does this actually look like in the real world? Let's check out a case study of a system called Astrogator to see how this all fits together. So the way Astrogator works is by building this chain of trust around the AI, which it knows is unreliable. So, step 1, a user just says what they want in plain English. Then an LLM translates that goal into a formal machine-readable query. Now, here's the most important part, step 3. A human, a real person, looks at that formal query and confirms, yep, that is exactly what I meant. That human confirmation is the anchor for the entire system's trust. Only after that does a totally different, completely untrusted LLM go and generate the actual code. And then the final step, an automated verifier comes in and mathematically proves that the code it generated perfectly matches that plan the human already approved. And this reveals a totally different way of thinking about AI. The key insight is brilliant. You don't have to trust the AI at all. In fact, you assume it's going to mess up. You trust the process that chucks the AI's work. The trust isn't in the AI, it's in the verification. It's in the proof, not the probability.
And does it work?
Oh yeah, it works. In their tests, that formal verifier in Astrogator correctly identified and rejected over 92% of the flawed programs the LLM generated. That is a seriously effective safety net. So this all brings us to the really big question, right? How does an idea like this scale? What does it mean for the future of software development for everyone, not just these highly specialized systems? You see, for decades, formal verification has kind of been this powerful but, well, niche discipline. It was just so hard and so expensive that you only really saw it used in these super high-stakes fields like avionics or nuclear control systems, places where a software bug could be catastrophic. But now, here's the great paradox of our time. AI, by generating so much subtly flawed and unreliable code, has suddenly made correctness a mainstream problem for millions of developers every single day. So, in this strange twist, AI's biggest weakness, its unreliability, is becoming the killer app that will finally pull these powerful verification tools out of the lab and put them into the hands of every single developer. And that leaves us with one last really big question to think about. As AI writes more and more of the world's code, are we on the verge of a brand new era? An era where the gold standard for software quality isn't just, hey, it seems to work on my machine, but instead, it is provably mathematically correct. That would be a monumental shift, and it might just be exactly where all of this is leading.